All right. I was explaining the last step that we are now safe to multiply the numerator with numerator and the denominator with denominator. So in this case, we're going to multiply 1 with y to the 7, z to the 2. We obtain y to the 7, z to the 2, divided by. Then when we multiply x to the 4 with 1, we obtain x to the 4. Now, ask me where you understand on that question. You understood everything, ne?
No, sir.
Yes.
Me, ne?
Yeah.
When I get to the second step, I go blank.
All right. Yeah. On this step. Let me explain this again. So what we do here, we have to change negative exponents to be in terms of positive exponents. And when we change x to the negative 4 to be in terms of positive exponent, we're going to obtain 1 over x to the 4. And then for y to the negative 7, we're going to have 1 over y to the 7. And then for z to the negative 2, we're going to have 1 over z to the 2. Did you understand that step?
Yes.
All right. Then from there, we focus on the denominator that we have here, because you can see there are two terms which are multiplying to each other. So on these two terms which are multiplying to each other, you can multiply their numerators and their denominators. So the numerators in this case is 1 and 1. When you multiply them together, you're going to obtain this one that you have down there. And then you multiply y to the 7 and z to the 2, which when you multiply them together, you're going to get y to the 7 and z to the 2. That is all we have done up to this step. So I would like to find out if you did not understand one of the steps we have covered up to here.
I understand.
All right. And then from there, I can tell you, or I can guarantee you, that there's no any other method we can use to deal with this many except the reciprocal theorem. So the reciprocal theorem, we have to change the big division to be in terms of multiplication. And once we effect the multiplication, we are going to swap the positions of the numerator and the denominator here, of which when we swap the positions of the numerator and the denominator, we're going to have this, which we are having on the other side of the board. And then because we have multiplication in between, I'll multiply this one with that. Also multiply with 1. We then get the final answer that we are looking for. Is it okay now?
Yes.
All right. But I'm not yet confident that you are all fine with these questions. So now let me look for other related questions which you can track. Because you can see on the questions we have done today, we're only focusing on 2 exponential rules. So the one that deals with the negative and the reciprocal theorem. So now let's deviate from the 2 theorems and we go to the 2 other ones. So now we're gonna focus on this question so that we apply the other theorem. Let's start with question number 3A. So on question 3A, I'll do the question. You will try other ones after I finish this one. So we have p to the power negative. Let me write it down.
So we can't see.
Yes, I'm writing down there. So I'm now doing question number 3A, which is p to the negative 3 multiplied by p to the power 2. The question requires us to simplify that expression. So how are we going to simplify this expression? Remember, this is just the number. We have p to the negative 3 and p to the power 2. So we have to apply exponential rule to deal with this question. The first thing you can do is to check if the bases are the same. So if bases are the same, the rules say that we now add the what? Exponents. Only if bases are the same. Confirm to me, are the bases of these two exponents the same?
Yes.
Yes.
What is the base?
P.
P.
P. Yes, definitely. So if the bases are the same, we can add the exponent. So we are going to have P, we just write one of them. So it's P to the power of addition of the exponent to the power of 3 plus 2.
Plus 2.
Because we have to add them according to the rule.
Yes.
Yes.
Then from there, we'll have P to the power what? Can you tell me the exponent you're going to have?
1. Negative 1.
Negative 1.
But you can see this is in terms of negative exponent. Can we change it to be in terms of positive exponent?
1 over P.
You can write it as 1 over P. And that's fine. Is that fine?
Yes.
All right. Let me do the second question for you. You will try the third one. I'm choosing question number 8 to do for you, where we are given t to the power of negative 4, t to the power of 5, and t to the power of negative 3. We are required to simplify that question. So this is how we simplify this question. You check if the bases are the same throughout the given exponents. Now, tell me, are the bases the same in this given expression?
Yes.
And what is the base?
T.
Is t. If bases are the same, what do we do?
We add the exponents.
We add the exponents. So now, in this case, we're going to have t to the power of negative 4 plus 5 and then minus 3. Let me be clear here, because some of you may say I'm subtracting. I'm not subtracting, I'm just adding all of them. So the first one I added is negative 4, the second one I added is 5, and now the last one I'm adding is negative 3. We must be careful here. We are adding, not subtracting. Therefore, that's why I'm putting a positive here, of which here we are having a negative value. That's why I'm also having the brackets there, so that you can see that we have two signs which are multiplying to each other. We have the negative from the formula and the negative from the exponent. So now let's add this. But before you add, there's just one thing which you must remember. Let me check if you understood this. If we multiply negative with positive, what is going to be the answer of this? What's the multiplication?
Negative.
Positive times positive will give us what? Multiplication of,
Negative.
is it a positive or a negative?
Positive.
It's going to be a positive. You must remember all these things. The multiplication of negative and positive, what do you get when you multiply negative and a positive?
Negative.
Get a negative. When you multiply negative with negative, what do you get?
Positive.
Get a positive. Very true. So now here we are multiplying a positive with a negative. It means the sign that is going to replace this is what? It's negative.
Negative.
Exactly. So we're now going to have t to the negative 4 plus 5. And then now here we put negative, because multiplication of negative and positive is going to be negative 3. And then from there, we'll have t to the power of, we add these 3 values, negative 4 plus 5 minus 3. It will give us
Negative.
what?
Negative 2. Negative 2.
Negative 2. That's correct. But you can see this is in terms of negative exponent. Let's write it in terms of positive exponent. What can we write?
1 over t.
1 over t to the power 2.
Yes, very true. And that's all. about that question. Let me quickly
So
give
we just leave it like that.
last question before we go
Same.
we wrap up today's lecture. Actually, I'm giving you this as a homework because we no longer have time. Eh?
Adiba was talking.
Yes, yes. Adi, what are you saying?
I was saying that we just leave it like that.
Yes.
Yes, yes. You leave it like this.
Mm.
This is your homework. Your homework is on question number 3. So I'm gonna give you question number H and question number A, question number N, question number R. Okay, let me write them in detail for in case if you don't have this question. We start on the first one. Question number H is x to the negative 3, x to the 4. And then question number J is 4x to the power of 6 multiplied by 2x to the negative 9. And then question number N, we have t to the negative 4 multiplied by t to the power 3 to the negative 2. And then the last question is question number U, which is p to the negative 5 multiplied by t to the power 3, all divided by p to the power of 4, p to the power negative. These are the questions which I want you to try. When you are done, send them to me. I'll give you the solution of those questions. Is that okay?
Yes.
Yes.
All right. Otherwise, we are done for the day and enjoy the rest of your day.
You too.